So today we are going to talk about relational operators. Actually, we discussed relational operators earlier as well, but today we are going to discuss it little more in detail as how they work. Okay, we are going to look at the practical approach of this topic, relational operators. So relational operators are used to show the relationship between the operands. These operators compare the value of variables and determine the result in Boolean expression format. So all these relational operators, you will find they will compare the values of the variable, or even they can compare the values of a consonants as well, constants as well, sorry, and they will determine the result, they will give the result in they will give the result in a Boolean format. In which format they will give the result? They will give the result in a Boolean format. Okay, which you know very well what is the Boolean format. The Boolean format is either true or false. Okay, so our relational operators are, they are used to show the relationship between the operands. These operators compare the values of variables and determine the result in the Boolean expression format. Okay, so there are around 6 relational operators. Okay, so these are the name of those operators. We read them as greater than, less than, greater than or equal to, less than or equal to, and not equal to. This is how we read them, this is how we call them. Okay, and this is a symbol we use for the operators. This is a symbol we have, and we read this symbol as greater than. The same way, this is symbol we use as less than. Then this is greater than, equal to, this is less than, equal to, and this is exactly equal to, and then this one is not equal to. So these are our 6 relational operators. How we use them? So we can use them either by using a variables, or we can use them with the help of a constant as well. So greater than, now remember students, they get confused between greater than and less than. Remember, greater than looks like this, okay, and less than looks like this. Okay, so this is greater than, this is less than. Now this is greater than, equal to. Now there is a problem with greater than, equal to special. Okay, if you don't write it in the proper format, if you write greater than, equal to as like this, okay, so this will result in wrong output. Not wrong output, it will result in a syntax error, because what we say greater than or equal to. So the first sign I am going to write is of greater than, and then I will write the sign of is equal to. If I say greater than, equal to like this, then it will result in a syntax error. The same way, if I want less than, equal to, so what's the first word I say? I don't say equal to less than, I say less than, equal to. So the first sign I'm going to write is less than, and then I'm going to write equal to. Please understand, if I do it like this, then it will result in a syntax error. It will be wrong. It will be grammatically incorrect. Then is equal to is okay, no problem. But the next one is not equal to. Now what we say, how we read it as not equal to. So that's why the first sign I'm going to use is of not, and then I'm going to use the sign of is equal to. Again, be careful, if I use this operator like this, where I write the is equal to sign first and then not, computer will result it in a syntax error. So these are our symbols. This is how we should read them. This is the symbols. This is how we read them. And the format is we use them with 2 variables or 2 consonants, constants as well. So A is greater than B is written in this format. A is less than B in this format. A greater than or equal to, A is less than or equal to, A is equal to, and A is not equal. Now what it will result in? So you will find that it will result in either true or false depending on the value. So assume we take the value of A as 12. Here I am taking what's the value of A? The value of A is 12. And what's the value of B? The value of B is 4. So let's see if I write A as 12 and B as 4. And if I give the condition A greater than B, what it will evaluate? It will evaluate to be true because A is 12 and B is 4. So obviously 12 is greater than 4. So this answer will come out to be true. Why? Because A is really greater than B because A is 12 and B is 4. So if you write this expression, then it will result in true. Then the same way, A is less than B. What's the value of A? 12. B is 4. Is it true? No. So this will evaluate in false. The same way, A is greater than or equal to. Now A is 12. Is 12 greater than or equal to 4? Yes. In fact, it is greater than only. But still, understand, if I say greater than equal to, means even if the value of B is 12, the condition will be true because 12 is not greater than, but at least it is equal to. So this is also resulting in true. Now this will result in false. Why? Because A is less than equal to B. No, A is 12 and B is 4. So it is neither less nor equal to. So this is also false. Now A is equal to equal to. Here it is exactly checking whether the value of A and B are exactly the same. So they are not same. A is equal to B. No, A is 12 and B is 4. They are not same. So it comes out to be false. And the last expression, which is A is not equal to B. What's the value of A? 12. B, 4. So A, 12 is not equal to 4. We know that very well. So that's why this expression will come out to be true. So understand, we can use these relational operators. We required it most of the time in the programming, but we can use these relational operators. They are 6 in numbers. Remember how we read them, how we write them, and how it works. Okay. We have another operators, that is logical operators. Let's talk about logical operators now in detail. So what are logical operators? So logical operators are the operators that are used between two or more conditions in a Java expression. So whenever we are having two or more conditions in Java, then we have to use logical operators to conclude the answer. The result is again, as we have relational operators, the same way logical operators also result in true or false, depending upon the values and all the conditions. So remember, whenever we have a scenario where there are two or more conditions combined together, then we use logical operators and they result in as of relational operators, even logical operators result in true or false, and it all depends upon the values in all the conditions. So let's understand it with the help of a table. We generally use logical operators to construct a complex decision-making expression. Exactly, yeah. So in programming, we do require to construct a complex decision-making expression, and there we are going to use our logical operators. Logical operators are classified into three types, and this two sign is read as and. Okay, so what is the logical operator I am going to use? So I am going to use and. So when I use and, what is the symbol I am going to use? So I am going to use two ampersand together and we call it as logical and. Then we have logical or. So we use two pipe sign, okay, which is there on your keyboard if you check it carefully. So this is the two, this is read as pipe sign. So these are two pipe signs together and we read it as or. And the third logical operator is the exclamation sign, which we read as not. So logical operators are three in numbers: logical and, logical or, and logical not. The logical and written as ampersand ampersand is a binary operator that combines the result of two or more relational expression. Exactly. It's a binary operator. Why it is binary operator? Because we use it with two operands, A greater than B and A less than C. This we are going to use it with two operators and combine the result of two or more relational expressions. It returns true. Now this is very important that how the logical and works. So remember this is very important. It returns true if all the expressions comes out to be true. Otherwise, it returns false. So this is a very important line which I am highlighting, that it returns true if all the expressions are evaluated to true. And otherwise, if it is not, then it returns false. So understand, and operator will return true if all the expressions, obviously, we are going to use and operator for more than one expression. For one expression we don't require, then we can do it successfully with the help of a relational operators. But if there are two or more expressions, then we require logical operator, and according to our requirement we can use and, or we can use or we can use not. But understand how the and operator works. And operator works, or it returns true only if all the expressions are evaluated to be true. Otherwise it returns false. Let's understand it with this table. Okay. Now understand, as I said, it has two or more relational expressions. So which are those two or more relations? This one. This is the first expression. This is the first expression. Pi is greater than. This is the first expression. Now here what I have used? I have used a constants. Even you can use a variable. Just for the simple understanding, we are use a constant. So 5 is greater than 3. And 15 is less than 25. So here, these are my two relational expressions. Now, what will be the result of this and this? So these two relational expressions are combined together using and operator. Okay, so how it will come out to be? So see, pi is greater than 3. Is it true or false? So you will find pi is greater than 3. Yes, so it is true. And 15 is less than 25. Is it true or false? So you will find 15 is less than 25. Yes, even this is true. So 5 is greater than 3 and 15 is less than 25. Both evaluates to be true. This expression comes out to be true. The second expression also comes out to be true. And what I have done, I have joined these two expressions with the help of a logical and. So how the logical and will work? It will return true if all the expressions are true. So here both the expressions, there are two expressions and both of them are true. So the result will be true. Why? Because both the expressions are clear. Now let's look at the second one. This is the first expression. 15 greater than or equal to 15. Is it true or false? So definitely 15 is not greater than 15, but it is equal to. So obviously this is true, because 15 is not greater than, but it is equal now. So this is true because 15 is not greater than, but it is still equal to 15. So this comes out to be true. And 20 is less than 16. Now what do you think? Is it true or false? So you will find 20 is not less than 16. 20 is more than 16. So this is false. So one is true and the other is false. And which operator is there? So you will find there is and operator. So 15 greater than 15 is true, 20 less than 16 is false. Means one of the two operator is false. And how the and will work? It will give true only if all the expressions are evaluated to true. So here you will find one is true and one is false. So the result will come out to be false. Why? Because our second expression is false. So since the second expression is false, so that's why this result will be. Now let's talk about the third one. Okay. Now 25 is equal to 20. Is it true or false? So you will find 25 is equal to 20. No. 25 is equal to 25. It is not equal to 20. So this is false. But what about the second condition? You will find 50 is greater than 30. Yes. So one is false and the other is true. And if I combine them together, you will come to know that one is true, one is false, and it's an AND operator. And for AND operator to result true, it has to have all the expression true. But here one is true and one is false, so that's why it is false. Okay, so that's why we have answer is coming out to be false. Why? Because the first expression is false. Now let's talk about the fourth expression. What we observe here, 18 is not equal to 18. Is it true or false? So we know 18 is equal to 18. So 18 is not equal to 18 is false. So this is false. 50 is equal to 60. Again, 50 is not equal to 60, but here it says 50 is equal to 60. So even this is false. So both are false. Since both of them are false and it's an AND operator, so automatically our answer will come out to be false. Why? Because both the expressions are false. Now, here I am just giving you the explanation part of it, how it works. 5 greater than 3, 15 less than 24. But in actual, we are not going to use numbers. In actual, we are going to use variables, and these variables will evaluate to be either true or false depending on the condition of our program. Okay, so I hope you are getting it how the logical and works. It works when it evaluates to be true only if all the expressions are true. Now again you may be assuming, sir, but here there are only two expressions. So it works only with two? No, it can work with multiple expression as well. Like 5 is greater than 3 and 15 is less than or equal to 25 and. I can write one more condition here. What? And here I can say 78 is not equal to 80. Now what you will find? You will find the first condition is true, the second is also true, and even the third is true. 78 is not equal to 80. So all three are true. So what will happen? This will again result to true because all the expressions are true. So don't think that only two expressions are being checked. We can use as many expressions we want because and is used for more than one relational expression. I hope your idea is very clear about how the logical and works. Okay, let's start with our logical or. Okay, we are having some doubt. Okay, so it's very clear to you. You all are very clear. Don't worry. After this, I will show you as how it actually works. Now we will talk about logical OR operator. Okay, so how the logical OR works. So the logical OR written as we are going to use two pipe signs. Okay, now this is a symbol which is there in your on your keyboard. Okay, it is there on your keyboard, but we have already rarely used it. Okay, so if you find in some keyboard it is above the enter key, somewhere in some keyboards it is somewhere else. So the location is not fixed on the keyboard, but this sign is there. We read this sign as a pipe sign. So the logical OR written as we have to use twice the pipe sign. Okay, as for and I have written ampersand twice. The same way for logical OR, it is written pipe sign twice. It is a binary operator that combine again. It is same as and combine the result of two or more relational expression. It returns true if any one of the expression are evaluated to true. Now understand, this is the way it functions. It functions, it returns true if any, this is very interesting, if any one of the expression evaluated to be true. So if any one is true, it results in true and returns false. And very interesting, you should remember when it returns false. It returns false only if all the expressions are evaluated to false. So understand, for or, you need to understand that all the expressions has to be for or operation. For all the expression has to be false, and it will be true even if one expression comes out to be true. So let's look at it how the or works. Okay, so we are using almost the same expressions. So 5 is greater than 3. 5 is greater than 3. Is it true or false? Yes, it is true. 15 is less than 25. Yes, it is true. So my first is true and the second is true. So obviously, what it will result in? It will result in true, because obviously both of them are true. So it will result in true. But let's look at the second one. 15 is greater than or equal to 15? Yes, 15 is greater than 15. No, 15 is not greater than 15, but 15 is equal to 15. So this results in true. And the next one, 20 is less than 16? No, this is false. So one is true and the other is false. So understand, one is true and one is false. If you recollect, and was saying it as false. But if you use or operator, you will find that the or operator will result in true. Why it is true? Because my one expression is true. So what the result is, pay attention here. It returns true if any one expression is. So obviously out of these two, one is true. So that's why it is returning true. You will say, what about 3? If there are 3 expressions, then if there are 3 expressions, even one out of those 3 is true, it will still result in true. If you say if there are 5 expressions, then so even out of 5 expressions, if even one expression is true, it will still result in true. So understand, or operator works in such a way that even if any one of the expressions are true, it will return true. And for or to return false, all the expressions have to be false. Now here, 20 is greater than 25. Sorry, 25 is equal to 20. No, so this is false. And what about the second one? 50 is greater than 30. Yes. So one is false, the other is true. But one is true. No. So it will result in true, because the second expression is true. And here you will find the 18 is not equal to 18. This is wrong, because 18 is equal to 18 and 50 is equal to 60. Even this is wrong. So you find both the expressions are wrong. So here both are false, and that's why the result will come out to be false. So understand, if the OR operator has to return false, it will return only if all the expressions are evaluated to false. So you understand the very basic difference between and or. Let me explain you a very basic difference between and or. Okay, and will result true if all the expressions are true, and or will result false if all the expressions are false. Okay, let me give you a very nice example which I generally give to all the classes, your result. Okay, you are generally, chalo, during the lockdown now you are getting the result as pass, but normally you must be aware that how you get the result as pass and how you get the result as fail. So you know very well, you get the result as pass if you pass in all the subjects. Exactly. If you pass in all the subjects, means you have to pass in English, you have to pass in maths, science, uh, history, geography, Hindi, computers. So you have to pass in all the subjects, and then only your result is pass. So how we find out whether the child is pass or fail? So we find it by using an and operator. English marks greater than 40. Hindi marks greater than 40. Science marks greater than 40. History, civics marks greater than 40. computer marks greater than 40. So if the child is scoring in all these subjects more than 40, so then and then only we declare the child to be pass. So which operator we are using? We are using AND operator. English greater than 40 and Hindi greater than 40 and French greater than 40 and math greater than 40 and science greater than 40 and computer greater than 40 means if all these expression will come out to be true, then the child is passed. But if the child is fail in any one subject, so what will do? It will result in false. It will result in fail because we know how our grading system is. If you want to get promoted to the new class, to the higher class, you have to pass in all the subjects individually. Okay, so which operator we use? We use AND operator. Okay, and how the OR operator works? Even if one expression is true, it returns true. So imagine, that's a very interesting idea. Just imagine if instead of using AND operator, if we use OR operator to find the result. Exactly. Instead of using AND operator, if you use OR operator to find the result, do you know what will happen? You will find that a child, even if he passes in any one subject, he will be promoted. If he even clears, passes in any one subject, he will still be promoted because we are using OR operator. OR will result in true even if any one expression comes out to be true. Okay, so if a child has to fail, he has to in fact fail in all the subjects. If the child fails in all the subjects, then he will be failed. But if he has to pass, then even if he pass in any one subject, then he will be promoted. The problem is we don't use OR operator in our education system. We use AND operator. For that, the child has to pass all the subjects. Let's start with the next operator, and our next operator is logical NOT. Okay, so this is our next operator, which is logical NOT. Now, how the logical NOT works? So the logical NOT is written as we use an exclamation sign, and it is a unary operator. Understand the difference between logical AND, logical OR, and logical NOT. Logical and OR, they are binary operators because they are used with two expressions. A is greater than B and B is greater than C. So we are using two expressions. But the same is true with logical OR as well. But when we talk about logical NOT, my logical NOT is a unary operator. Unary operator means which deals with only one operator, which deals with only one operand or one expression. So it deals with only one expression or a group of expression evaluating to one. Or we can have a group of expression, but the result of that expression comes out to be one. Okay, so we can use logical NOT for that. And how it works? So this is the again very important thing you have to remember about logical NOT is it reverses the result of the expression. It reverses the result of the expression following it. Okay, so whatever the expression which is following it, it will reverse. Reverse means what? It will make it exactly opposite. Now, obviously, we know there are only two outputs. One is true and one is false. So, if it is true, it will make it false. And if it is false, it will make it true. So, it reverses the result of the following expressions following it. For example, if the expression returns true, then NOT operator returns false and vice versa. If the expression is resulting false, then the NOT operator will result it in true. So it will just reverse the outcome. It will just reverse the outcome. See how it will reverse the outcome. Pay attention. Now 5 greater than 8. Look at this. 5 greater than 8. Is it true or false? So you will find 5 is greater than 8. No. So this is false. So this results in false because 5 is not greater than 8. So 5 is greater than 8. This is false because 8 is greater. So this is false. But since this is false, so this expression comes out to be false, but we are using a not in front of it. So what this not will do, it will reverse the outcome and this will come out to be true. Why it will come out to be true? Because this expression is false and the not of it will reverse it and it will be true. Why? Because 5 is greater than 8 is false and the reverse of it is. Now let's look at the another way. 21 is greater than or equal to 50. Is it true? And you will find yes, 21 is greater than 15. So 21 is greater than 15. So this is true. But the interesting part is there is a not in front of it. So what the not will do? The not operator will reverse the outcome, and that's why though the expression is true, the not will reverse it and it will return false. So you find why it is false? Because this expression comes out to be true. Now this is for one relational expression. This is one, this is one. But I said that the logical not deals with one operand or a relational expression or a group of expression evaluating to one. So now the next two examples are a group of expression. Look at this. This is my group of expression. This is a group of expression. Okay, this is also a group of expression. Okay, now see what happens. So 25 is equal to 20. Is it true or false? So you will find 25 is equal to 20. It is false because 25 is not equal to 20. But here it says, are they equal? No. So this is false. And 50 is greater than 30. Is it true or false? So you will find 50 is greater than 30. Yes, 50 is greater than 30. So you will find this is wrong. This is right. Means one is false. The other is true. And which operator is there? The operator is or. And how the or works? So we know very well, if one is true and one is false, and if there is a or operator, it will result in true. So the overall output of this expression is true. What is the overall expression? What is the overall output of this expression? It is true. And we are using not of true. So it is a not of true, and that's why it is false. Clear? So it's coming out to be false because this expression is coming out to be true. And since this expression is true, the reverse of true is false. And that's why our answer is coming false. The same way, look at this. Now, what is this? 18 is not equal to 18. Is it true or false? So you will find 18 is equal to 18. So this is false. Because it says 18 is not equal to 18, which is wrong. 18 is not equal to 18. 18 is actually equal to 18. So this is wrong. And 50 is equal to 60. What it is? Even this is wrong. So we know this is wrong. The second is also wrong. So both are wrong and it is a OR operator. So both are wrong and it is a OR operator. So what will happen? The overall result will be false because both are wrong and it is a OR operator. So the overall result will be false. But then we have written a not before that. So what it will do? It will reverse the output and false will convert into true. So that's why we are getting the answer here as true because this expression is false. So this is again very interesting. Logical not. Remember something very important about logical not, that it is my unary operator. It deals with one operand or one relational expression or a group of expression resulting in one output. And what it will do? It will reverse the result of the expression following it. Is it very clear, bachcha log? There is a logical and, logical or, and logical not. Okay. Hope you are getting it. Now the next one, the precision of data type. Okay, so what is the meaning of the word precision of data? So you need to understand that it is about the number of decimal places we are going to get when we are using two double data type or two float data type. For example, I have given integer integer a sorry integer no sorry float a is equal to 10, okay, and b is equal to 3. So we are having two expressions, float a is equal to 10 and float b is equal to 3. Now if I use a divided by b, so you all know that when 10 is divided by 3, our answer is 3.33333, and it is recurring, it is forever 3.3333 exactly. But when you are going to use this expression, when you are going to use it, when you are going to use this, okay, I hope you can see it. So whenever we are going to use it, and if I use a double data type, then you will find that this expression a divided by b will give me 3.33, but up to 7 decimal places till 7 decimal points, means from a decimal point to 7 digits. So it will give me 3.3333 till 7 digits, 7 points. And if I use double, that I have used double A and double B, and then I use A divided by B, then my answer will be accurate to 16 decimal place. Okay, let me explain this idea very well with the help of our software itself. Let's understand. This will help us to make it very clear how it is working. So here I have float A is equal to 10. I will write F in front of it, and float B is equal to 3, and float, since it's float, I have to write. Now the result will always be float, but I am not writing it. I am directly printing the answer. Println A divided by B. Now my A is float and my B is float. Okay. And A is divided by B. Means 10 divided by 3. So we know what's the answer of 10 divided by 3. You see what we are getting. We are getting 3.1, 2, 3, 4, 5, 6, and 7. So we are getting the answer from decimal points. We are getting answer accurately to 7 digits. Exactly. What we are getting 3.3333333 means we are getting it accurately up to 1, 2, 3, 4, 5, 6, and up to 7 digits from the decimal point. Okay, so this is how we are getting the answer. Now I will take double x is equal to 10 and double y is equal to 3. So the data type is same, the value is same. The only thing what I am doing, that now I am taking double data type and I say x divided by y. Now what is x divided by y? It is 10 by 10 divided by 3. So what will be the answer? So answer is still the same, 3.33, but since I have taken the data type as double, you will find out, see the accuracy. So you will find here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you find that it is accurate till 16 digits from the decimal point, whereas this is accurate up to 6 digits, whereas this is accurate up to 16, sorry, this is accurate up to 7 digits, and this is accurate up to 16 digits. So this is what I was talking about, precision. So whenever you want to get more precise answer, you should prefer double or you can prefer float. But one thing is pretty sure, that up to 6 decimal place or 7 decimal place accuracy is more than enough. Okay. Like if I say the value of pi, what is the value of pi? 22 by 7. So if I take A as 22 and B as 7, so we know 22 by 7 is our recurring number. It's an irrational number. And the same way 22 by 7. So this is nothing but this is the value of pi. Now if I do it 22 divided by 7, my answer will be 3.1415 for C. This is my answer, 3.14152857. So you'll find it is accurate to 1, 2, 3, 4, 5, 6. Okay. And here you will find it is accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. So here they are accurate to, here they have more accuracy as compared to others. Okay. So this is what I was actually talking about precision. I hope your idea is very clear now when we talk about precision. So here you write down this is up to 6 decimal places and this is up to 16 decimal places. Sure. Now integer and real conversion. Again, a very, very important topic. Okay, a very, very important topic to remember because you may end up doing a lot of mistakes in this very particular topic. So what is that? So you know that in Java, when the integer is operated with another integer data type, if one integer data type is operated with another integer data type, the result is always integer. Remember, integer is operated with integer. We have discussed about this in our precedence of an operator, where we have seen whenever the operation is between integer and integer, the result is always going to be in our mixed expression. We have discussed about it. Okay, so for addition, subtraction, and multiplication, there is no problem. Okay, there is absolutely no problem with the way the Java functions and our general maths function. There is no problem in addition, subtraction, and multiplication. But when it comes to division, it gives us the wrong answer. It means the Java program gives us wrong answer. How? Let me explain. Assume that we have integer a as 5 and b as 2. So what's the value of a? 5. B 2. And both are integer. Remember, they are integer. They are not double. They are integer. Now, if I write a plus b, so what is the value of a? 5. What's the value of b? 2. So what is the answer? 5 plus 2 is 7. But what is 7? If you check the data type of 7, 7 is integer. So integer plus integer is coming integer. The same way a minus b. What is a? Integer. What is b? Integer. So 5 minus 2 is 3. And what is 3? So you will find that 3 is also our integer. The same way a into b. So what you will find? A is integer and b is also integer. So 5 2s are 10. Even 10 is integer. But you may be wondering that what is this? There is no big sense in it, but yes, there is. Now a divided by b. I'm so sorry, it's not 2. A divided by b. Sorry, just assume it as b. So a divided by b is 5 divided by 2. Now what is the 5 divided by 2? What's the answer? So the 5 divided by 2, the answer in math is 2.5. Now look at this idea. Okay, it will make your concept very clear that when I say this 7, it was integer. This 7 was integer. Yes, this 3 is also integer. This 10 is also integer. But what about this 2.5? Is it integer? No, 2.5 is a decimal number. Okay, but what computer will do when I will use a divided by b, where value of a is 5 and b is 2, computer will return only the integer part of it. And what will be our answer? So our answer will be 2. What will be our answer, class? Our answer will be 2. And so it is incorrect. So you have to be very careful whenever you are using any operators with integers. And you have to be very careful when that operator is a division operator. If it is addition, Still, we have no problem because when 2 and 5 is added, the answer is integer only. We cannot get 5 plus 2 as 7.3. You will never get this answer. 5 plus 2 is 7 only, and 7 is also integer. The same way, 5 minus 2 is 3, and 3 is integer. So there is no problem because we will never get 5 minus 2 as 3.3. You're getting it? So when we have two addition of integer, the result is integer. Two subtraction of two integer will be integer. Multiplication of two integer will be integer. But the division of two integer will result in decimal. There is a possibility. Not always. You will say, sir, 10 divided by 2. If you do, the answer is 5. Yeah, so that is true. But there is a possibility. There is a possibility that your answer may come in a decimal, but what computer will do? So you will find that the computer will return only the integer part of that question, that answer, and that's why this is incorrect. This result in wrong output, and in fact our calculation goes wrong. So the problem is how to solve, how to get the right answer out of it. So it's very simple to get the right answer. Okay, it's very, very simple. What you have to do, you have to convert any one data type to double. What you have to do, it's very simple. You just convert any one data type of it to double. Okay, let me show you this. This is again something very important that needs to be understood by looking at a practical approach. Okay, let's do it. So my integer a is 5, comma b is 2. Okay, now I am doing all the operation. System.out.println a plus b. So this is addition. Then okay, now here I am doing addition. Here I am doing subtraction. Here I am doing multiplication, and here I am doing division. Okay, in fact I can use modulus as well. Okay, and you will find the modulus will also be right. Okay, so let me show you that as well. Okay, so let me show you modulus as well, because these are our 5 arithmetical operators. Okay, so 5 modulo 2 will be 2. Remember that 5 modulo 2 will be 2. Okay, so all are correct. Remember, the first is addition, second is subtraction, third is multiplication, fourth is modulus, and the fifth line is our division. See what we get. So see, addition is right, subtraction is right, multiplication is right, modulo is 5. So yeah, the answer is 1. And here, this is what I want to highlight. What is this? So you will find my answer is coming 2. Now 5 divided by 2. Is the answer 2, bachalo? No. If you check it, my answer, if I make all these as comments because we have to work on this part only. Okay. What a divided by b is resulting in? So you will find a divided by b is resulting in 2, whereas the answer is wrong. Okay, so what to do? Okay, or I can do it the other way. If I write integer a, so integer ans is equal to a divided by b, and if I write here ans, see, you will find my answer is coming out to be 2, which is wrong. So what is the solution? So solution is very simple. What you do, you convert any one data type to double or to float, either of it, whatever you want. So what I did, I keep a as integer, but I have changed b to float. So now my b is float. Now here, obviously, when I'm going to store it, obviously we know the operation between integer and float, the result of this has to be stored in a higher hierarchy, that is float. So let me store the answer in float. Okay, and see what. Now here, one is integer and the other is float. You have to be careful. You have to take this action, and your answer is coming 2.5. Getting it? Now your answer is right, because integer is divided by float. Or you can do it Either you can convert it into double as well. Okay, so obviously now here you will find when the operation is between integer and double, the resultant has to be to the higher hierarchy, and that is double. Okay, now here again you will find your answer is coming right. Okay, so that is something you have to be very careful of. You have to be cautious about this, that whenever you are performing an operation between an integer and an integer, and more importantly, when both of them are, sorry, and more importantly, if you are using a division operator. Okay, so you have to be very careful that your answer will only be the integer part of that. Okay, like let me discuss it with one more example. Okay, let's see this example. We have integer marks obtained. Now, how much is the marks obtained? Assume the student has scored 400 and 541, and integer total marks MRK. And how much is the total marks? MRK, short form. Now the total marks is, it's out of 700, the student has scored 540. Now, how we calculate the percentage? So assume I want to calculate the percentage. So we know what's the percent, how we calculate the percentage. The percentage is marks obtained divided by total marks into 100. So let me write it, MARKOBT, mark obtained divided by total marks, TOTAL into 100. Yes, that's the formula to find out the percentage. Marks obtained divided by total marks into 100. Okay, now see what's the answer, what's our percentage. If a child is scoring 541 marks out of 700, see the percentage. And you will be very much surprised to see the percentage is coming out to be 0. Why the percentage is 0, class? Because 541, when you divide by 700, okay, let me show it with the help of a calculator. Okay, okay, so now what I'm doing, 541 divided by 700. What's the answer? So you find the answer is coming 0.7728. What's the answer? 0.7728. But 0.7728, if computer takes the integer part of it, it will be only 0. And 0 is multiplied by 0. What's the answer? The answer is 0. So that's why your percentage is going wrong. So what's the solution to this? So you do one thing, you convert your total marks to double. Convert any one data type to double. Okay. Now see what happens. And you will be surprised that now our answer will be right. How much is the percentage? 77.28%. So you have to be very, very careful, class. You have to be very, very careful whenever you are using division and you are using all operators. When you are using division sign and you are using integer operator. Okay. Now let's talk about the last topic. There are the types of errors in Java. So basically there are 3 types of errors in Java. The first we called as syntax error. The second we called as logical error. And the third and the important type of error which we come across is our runtime error. So these are the 3 types of errors which we generally come across whenever we are writing programming in Java. Which are these 3 errors? Syntax error, logical error, and runtime error. Now, what is syntax error? So syntax error occurs due to the grammatical error in the programming language. It may be missing of a punctuation sign, or you write an incorrect instruction, or you use a undefined variable. So whenever you make a mistake in the grammar of the program, then it results in a syntax error. What is logical error? Logical error is the error which occurs in the programming logic. In this case, you will find the program is compiled successfully and it also gives us the result, but the result is not what we expect. Okay, so that is called as logical error. This error is called as logical because it is the error in your logic of the program. Okay, so definitely logical errors are the ones which are very much difficult to figure out because this is the error in your logic. There is no error in the syntax of the program. So most of the time, if the logic goes wrong, your answer goes wrong, and you may be wondering that computer is giving me the wrong answer. The computer is not giving you the wrong answer. The logic behind that program is incorrect. So that's why we call it as a logical error. And the third type of error is runtime error. This is the error that occurs at runtime. Runtime when the program is executed. When the program is executed after compilation, when I right click on it and I give the input, and when the program is executed, during that time, this type of error comes, which we call as runtime error. This generally happens when you divide a number by 0 or try to find out the square root of a negative number and so on. So this runtime error is something which we are going to practice a lot. In our programming, we will definitely come across most of the runtime errors. Okay, so these are the three types of errors which are found in Java: syntax error, logical error, and runtime error.